Hello everyone. This is a session on pipelaying for Jica Okinawa's training course, Small-Scale Water Purification by EPS and Management Techniques in Water Supply Services. I'm Akira Teruya from Engineering Division of Nago City Environment Waterworks Department. The subtitle of this session is Constructing a Leak-Free Pipeline System. In this session, I'll introduce a standard waterworks engineering procedure in Nago City. Now, let me introduce the objective and contents of today's lecture. I stated a leak-free pipeline system in the previous slide, but let me clarify here. All pipes will leak at some point due to aging. Under Japanese law, service life of ductile iron pipes is 60 years and 40 years for PVC pipes. After that, leakage due to aging can happen, but when it actually does, depends on places of installation, installation method, and installing techniques. Recently, in Japan, some piping products are advertised to have a century-long service life. Using such long-lasting piping materials can reduce the frequency of aging pipe replacement. The gray and blue pipes shown on the photo are examples of such long-lasting pipes. In other words, the most important thing is to develop a pipeline system in which no pipe will have a leak until the end of its service life. Even if we install a pipe with a century-long service life, we will have to replace it before it performs to its full potential unless we install it properly. Such pipes may have high initial cost, but thanks to its long service life, their total cost will be low. In this session, I'll introduce the standard pipelaying method in Nago City. There may be some differences between our method and yours, but I encourage you to try and adopt anything that you find useful. Now, let me begin with the introduction of Nago City, where I work. Nago City is located in the northern area of the Okinawa main island. It was created back in 1970 with a merger of 5 municipalities. Last year, in 2020, the city celebrated its 50th anniversary. As of the end of March 2020, the number of population was 63,000, and the number of households was about 30,000. The area of the city is 210.9 square kilometers, the third largest in Okinawa. Mountains and forests account for most of the area, and there are many rivers, large and small. They are our source waters for water supply service. The bottled water in the picture has our tap water inside. It is not for sale, but we distribute it at various events in the city, as well as keep it for emergency. Many citizens gave us favorable reviews, saying that it tasted better than tap water they drink every day. Next, let me introduce Nago City's water supply service. It started from water supply service for 70 households in 1935 and expanded gradually until today. We now supply drinking water to about 60,000 people or about 29,000 households. While the area of the city is 210.9 square kilometers, water supply area is 59.01 square kilometers, or 28% of the city area. The remaining 72% is areas without communities, such as mountains and forests. In Nago City, we have 2 water purification plants, one with daily treatment capacity of 18,500 cubic meters for supplying water to the western side of the city, and the other for the eastern side with that of 4,500 cubic meters. Source waters include groundwater, rivers, and dams. Purification method is rapid sand filtration with coagulant. Since the western side of the city has a large population that exceeds our supply capacity with our own source waters, we supplement it with purified water purchased from Okinawa Prefectural Enterprise Bureau. We have 11 service reservoirs throughout the city in order to store and distribute purified water from purification plants. In addition, we also have other facilities such as booster pump station. We remotely control all those facilities from the central monitoring room of purification plants and constantly monitor abnormalities to respond immediately. The number of our regular employees for water supply service is 21, but if we include workers for outsourced tasks, including operation and maintenance of purification plants and pipelines, as well as bill collection, 70 people are working for water supply service. Our total annual distribution amount is about 8 million cubic meters. Revenue water accounts for about 7.3 million cubic meters, which gives us revenue water rate of about 92%. We suspect that about 5% of non-revenue water is due to leaks from aging pipes. Although locating leaks is challenging, we have succeeded in finding many of them by narrowing down suspected leak areas with block meters and considering the types of pipes, followed by leak detection work at night. Such efforts led to gradual improvement of revenue water rate year by year. The total length of pipelines that we manage is 514 kilometers. The value is the total length of all the raw water transmission pipes from intake station to purification plants, water transmission pipes from purification plants to service reservoirs, and service pipes from service reservoir to households. From here, let me move on to the main topic for this session, pipelaying. Let me first introduce two implementation procedures, directly managed construction and outsourced construction. I heard that all the pipelaying works in the city were directly managed until more than 50 years ago, but they are all outsourced now. Let me explain directly managed construction first. It is a construction project implemented directly by the Waterworks Department without outsourcing. Its advantages include lower construction cost with direct installation by in-house staff members, shorter construction period thanks to reduced administrative procedures for contract, etc., maintained staff members' technique by constructing directly, prompt emergency response due to not having to ask contractors to do so. And disadvantages are hiring enough staff members, which increases labor cost, procurement and management of construction material and equipment is necessary, which increase our property. Lack of competitors leads to lack of competitiveness and insufficient opportunities to improve technical skills. And lastly, implementing construction work in one's own way slows down legal development, and quality may decline. Next, let me explain outsourced construction. Almost all municipalities in Japan choose this procedure, probably because there are many construction companies. Its advantages include stimulate construction industry, fewer in-house staff members required at the waterworks department, no need to procure construction material and equipment, rivalry among competitors ensure competitiveness and improved skills, ensure quality through project management by in-house staff members. And its disadvantages include high construction cost, longer construction period, contractor management is necessary, legislation is absolutely necessary, design documents needs to be prepared, outsourced work to internal work. I think which procedure to choose depends on each country's situation. I also believe turning some disadvantages into advantages can be entirely possible. In either case, we should never forget that the goal for construction projects is to ensure quality. We should always ensure pipes are installed properly, with no potential cause for leak. Next, let me explain relevant legislation for pipe laying. In order to ensure quality of construction work, we need minimum rules that all people involved have to follow. To do so, legislation and specifications need to be introduced in advance. In Japan, existing legislation include Act on Promoting Quality Assurance in Public Works and other specifications and rules according to the kind of construction. There are specifications for pipe materials as well. To put it bluntly, whoever the implementer is, as long as they follow those rules and material specifications, we can ensure minimum qualities required. Next, let me talk about the use of proper tools. Water pipeline construction requires various tools. Each tool has specific use, and basically, no tool is a universal tool. The photo on the left shows various types of drill bits used to make service connections. Specific type of drill bit needs to be selected according to the type of service pipe. The photo on the right shows the tool used for polyethylene or PE pipe installation. Basically, you should not start installation work unless you have all the tools in the picture. If you carelessly substitute a tool with others, quality will suffer, so please be mindful of that. Tool manufacturers develop each tool with good understanding of pipe characteristics to suit best. If such tools are used outside of its intended uses, the quality it is supposed to provide will not be assured. Even worse, it may have a negative impact on other sections. Let me explain further with an example of service pipe installation for supplying water to households. The photos below show examples of drilled holes to install a service saddle to a PVC pipe. The photo on the left shows a bad example. It used a drill bit for ductile iron pipes, not for PVC. As you can see, drilling was not done properly, and PVC pipe fragments remain there. Meanwhile, the photo on the right shows a good example. Proper PVC-type drill bit was used. You can clearly see the difference. One of the PVC pipe characteristics is that it breaks if sharp tools are used. The ductile iron pipe type drill bit has a pointed tip, and it forced itself through the PVC pipe. We can see that the use of an inappropriate tool not only failed to cut the clean hole, but also left the pipe itself deformed and distorted. If such work is repeated daily, it will shorten the pipe's service life and lead to leaks. Since drilling is usually done while water is flowing through pipes, you don't get to see such hole conditions often. Giving similar demonstrations at staff trainings would be a good idea. This is an example of staff trainings. We've set up a PVC pipe, like the photo above, in the office yard. I think it would be better if water pressure can be applied within the pipe by flowing water inside so that it resembles the actual condition on site. The photo on the lower left was taken to show the moment when the pipe was being drilled. When we experience something that we can't usually see, we can remember it at actual work. The photo on the lower right shows a participant drilling a pipe after cleaning the surface. By asking each participant to perform what they usually do in front of others, we often notice the improper installation method is common, or that there are individual differences in installation techniques. Lastly, we stopped water flow in the pipe and asked participants to check the condition of holes they had made. Now, let's take a look at waterworks construction in Japan. This is the standard procedure for pipe laying. First step is preparation for construction. Prior to construction, we conduct a survey to make sure the piping plan matches with the actual site. If we find obstacles at site, we'll revise the plan. The photo on the upper right shows trial excavation to check if there are buried objects other than water pipes. If we don't do this, we may damage these buried objects with construction machinery. If we damage high-voltage power cables, it will pose a serious risk to the worker's life. If we damage phone lines, internet and phone service will be interrupted, which will not only bother users of these services, but also incur compensation fee to communication service providers. The photo below shows placement of safety signs. When we work on road, we should always put vehicle and pedestrian safety first. To ensure vehicles and pedestrians can pass by the site safely, we put safety signs or sometimes create temporary sidewalk. The site foreman needs to ensure that these safety measures are functioning all right. Next step is excavation. The photo on the left shows the asphalt cutting process. The yellow machine cuts asphalt and sucks up dust at the same time. Suction of dust from asphalt cutting is necessary, as the dust is considered to have adverse health effects in humans. If you cut asphalt while pouring water, the water needs to be absorbed with sponge or other materials to dispose as industrial waste. The photo on the upper right shows excavation for pipe laying. When you lay a 100 millimeter pipe, the diameter of the trench should be about 60 centimeters. Excavated soil should be transported with a truck and temporarily be stored at a designated place so that it can be used for backfilling. The photo on the lower right is taken to prove that the trench depth matches with its design depth. Since pipes will be buried under the road, we have to make sure burying depth is exactly the same as designed in the plan. If a buried object is found at excavation, water pipe should be laid at least 30 centimeters away from it. It is the minimum distance required for maintenance operation of both objects. Next step is soil retention. Soil retention work is conducted to ensure safety of workers working in the trench. Retention work is necessary if excavated depth is more than 1.5 meters, when the construction work is done on soft soils, etc. For soil retention, steel or wood materials are used. Without soil retention, you may risk your workers' lives. Again, safety always comes first. Next step is pipe laying. First, we begin by checking to see materials are the same as designated in the plan. All the pipe materials need to be visually checked. If any material is found to be deformed or out of specification, it needs to be returned. The photo on the lower right was taken when a ductile iron pipe was installed. This is a pipe with a century-long service life that I mentioned earlier. Since it is made of iron, we wrap it with a plastic sheet for rust prevention. For iron to rust, both air and water are needed. If there is only one of the two, it will not rust. The plastic sheet is used to shield the pipe from air. It is simple but very effective. After the pipe is laid on the trench, a photo of the pipe is taken with number tags to identify where each material is used. Next step is backfilling. Backfilling is one of the important steps in pipeline construction. We are instructed by the road administrator to prevent road subsidence after burying water pipes. Therefore, backfilling material needs to go through soil test, and soft soil and other inappropriate soil will not be used. Backfilling is done with several 20-centimeter layers. If it is done at once, subsidence will occur later. If subsidence occurs, we have to lay pipes all over again, which not only increase material and labor cost, but also produce more industrial waste. Proper compaction is crucial to avoid such troubles. Next step is pipework chlorination and water pressure test. When a new water pipe is laid, its inner surface needs to be disinfected. To disinfect, the pipe is filled with a highly concentrated chlorine solution, with chlorine concentration of 10 milligrams per liter, and left for 24 hours. 24 hours later, residual chlorine concentration is checked, and if it is more than 5 milligrams per liter or higher, disinfection is done appropriately. All the chlorine solution used is transferred to a tank, and after chlorine concentration is lowered, it is discharged. In order to detect any leak in the newly installed pipe, water pressure test is simultaneously conducted with pipework chlorination. For ductile iron pipes, water pressure at 0.75 megapascal is applied for 24 hours. Water pressure is then measured for 1 hour, and if the water pressure doesn't go down, we determine that the pipe doesn't have a leak. The last step of pipelaying work is asphalt repaving. On the day of asphalt repaving, we need to complete asphalt spreading and leveling at designated temperature, rolling compaction, and reopening the site to traffic. On the following day, part of the newly paved asphalt is cut to check thickness. After completing all these steps, pipelaying work finishes only when it passes a strict inspection. If defects are found, they need to be repaired and inspected once again. Lastly, let me explain leak repair. When we locate a leak, we need to plan a suspension of water supply in the surrounding area for repair work. After we determine the area to be subject to water supply suspension, we notify the residents and stop water supply with valve operation. We then start leak repair work. This animation shows a bad example of leak repair. By cutting the pipe, water left in the pipe flows out from the pipe. Without a drain pump, the trench will be filled with the water right away, submerging the pipe. Draining the water with an excavator bucket is not fast enough. If we try to join submerged pipes, we would have to tighten bolts without being able to see those located at the pipe bottom. Since bolts have to be diagonally tightened with equal torque, we risk doing an improper work by not being able to check tightening condition of the bolt at the bottom. What would be the consequences of such improper construction methods? For one, turbid water would flow out of service taps at customer houses. Moreover, foreign objects may clog flow meter's turbine blade. If we only focus on repair work at hand, we may fail to foresee future potential problems. Leak repair needs to be conducted in a dry condition as much as possible. So, what could we have done to prevent this? This is the improved work method. The changes we make include the following: excavating larger trench to secure enough workspace for repair work. The trench should be at least 30 centimeters wider at each side of the pipe, making sure that bolts were tightened properly after leak repair. Excavating extra workspace would be helpful for using wrenches and other tools. Preparing a drainage way. It needs to be prepared to drain water flowing out from the pipe after cutting. Setting a drain pump. It needs to be placed at a lower ground than the working floor. Let's review the correct way with the animation. First, we cut the pipe. Drain pump must be operating already. Then, water remaining in the pipe flows out. Since drain pump is operating, the water is drained right away. Although some water may still flow out, we succeeded in creating an almost dry condition for repair work. We should always prepare and bring necessary tools and machines to the site by foreseeing what may happen. If we realize that we don't have a drain pump only after we cut a pipe, water will not stop for us. We should therefore make sure to prepare all the necessary things. After the repair, we finish with draining in order to disinfect the pipes later. Thank you very much for watching until the end. This session introduced general procedures for pipe laying and leak repair. If we were in normal times, we would have invited you to come to Nago City for observing actual pipe laying work and hands-on training. I'm sorry for not being able to do so this year, and for not being able to meeting you in person. I hope we'll have a chance to meet each other someday. If you have any questions, please write them down in the questionnaire. Thank you.